Hi all, here is a question that for a given circuit, assume the transistors are exactly matched, and beta is finite, that's equal to 100, and identify the value of n. Here, n is the number of output stages for the error in the output current to be less than 10%. This is a current mirror circuit. The base emitter voltages of all transistors are same connections. So if they are matched with beta equal to infinity, ideal case, then base currents are same, that's equal to 0. As beta tends to infinity, IC upon beta will tends towards 0, that's equal to my base current. So ideal case, if beta is infinity, 0 base currents implies 0 ampere here, 0 ampere here, 0 ampere here, 0 here, 0 ampere here, all are having infinite beta. So this branch current will be 0 amperes. It's sum of all base currents. Individual base currents are equal to 0. The sum also should be equal to 0. In that case, the I reference or IC reference collector current flowing into the reference transistor is same as my I reference because this branch current equal to 0. So as my base emitter voltages are same for all transistors and all transistors are exactly matched with beta equal to infinity, the collector currents of individual transistors are same as the collector current of the first or reference transistor. IC reference, IC reference, IC reference. Right? These are my output stages. I will call them as output current, and all currents are equal because base emitter potentials are same and they are matched. So my output currents I out is equal to, that's equal to I1 equal to I2 equal to I3 etc equal to IN. So that's equal to IC reference itself, and that's equal to I reference. Right? Same reference current flows to the reference transistor, and all other collector currents are same equal to IC reference, that's equal to I reference. In that case, if I out is same as my I reference, I will say that my error is equal to 0%. Right? I out and I references are same. This is the ideal condition of a mirror circuit in which the reference current exactly reflects at each output line of my transistors. In this example, in this question, beta is finite. If beta is finite, I'll have some other value here, right? And base currents are not equal to 0, not equal to 0, not equal to 0. They are finite, but not equal to 0. And output currents are not equal to IC reference, right? IC reference. So as my VPs are same, I will have same base currents, but that is not equal to 0 as beta is finite equal to 100. So I'll have a base current here. I will have base current here. All base currents are equal because the transistors are matched and their base emitter potentials are at same points. So I have n IBs here. This is n times of IBs because I have n number of transistors connected. I have another IB here. So this branch current is nothing but n plus 1 times IB, right? Applying Kirchhoff current law at that node, given node, collector of reference transistor, I have total current I reference coming into the node, and that is same as my IC reference, IC reference plus the other branch current is N plus 1 times IP. And as I said, IC reference is same as my I1 and it is same as I2, same as I3. So I will call it as I out, say current I out, because they are exactly matched. Betas are same, base emission potentials are same. So all currents I1, I2, etc. In equal to I0 or output current I out, and that is same as my IC reference. All collector currents are same. So I will write here that if the transistors are exactly matched, ICR equal to I1 equal to I2, etc. equal to IN, that's equal to I out. I'm calling it as output current. I. So the above equation reduces to I reference is the total current supplied, that's equal to IC reference is nothing but I naught plus what about IB? IB is nothing but the collector currents, they are same, equal to I naught divided by I naught is common, so 1 plus N plus 1 upon beta is my I reference. And my current of interest is output current I out. So from this I can write my I out as I out equal. Taking the LCM, I reference multiplied by beta divided by beta plus n plus 1. Here n is number of output stages 1, 2, etc. up to n. Right? Here in the question it is given that error to be less than 10% implies I out should be greater than 10% error implies I out should be greater than 0.9% of the reference current. I reference, right? And this is my I reference. Implies this ratio should be greater than 0.9. That implies beta upon beta plus n plus 1 should be greater than zero point 0.9. Beta is given as 100. 100 upon 101 plus n should be greater than 0.9. That implies 100 upon 101 plus n should be greater than 9 upon. That implies 1000 greater than 909 plus 9 n implies 91 greater than implies n less than 91 upon implies n should be less than 10 point n less than that number. I'm bounding to 10. So n is less than 10 implies the number that is less than 10 is n equal to. So you can connect up to 1, 2, 3, 4 up to I 9.